All right, so now for problem number 51, it said exiting from a small linear accelerator near Washington, D.C., a proton is moving parallel to the ground. What should the direction of its velocity be in order to maximize the upward component of Earth's magnetic force on it? Part B says using the value of 0.5 millitesla, or 0.05 milleteslas, for the value of the horizontal component of Earth's magnetic field at this location. What is the upward acceleration of the proton as it exits the accelerometer at a speed of 200 meters per second? Well, that's not that fast. It's not even close to the speed of light. That's slow. All right, so according to figure 19.30 here, the magnetic field at Washington, D.C., see they gave us this information, and that's about right there, points about 10 degrees west of true north, okay? It points about 10 degrees west of, really Washington's over here, but it's in that 10 degrees west of due north, okay? And so for a maximum vertical force, the proton's velocity should be perpendicular to the field. Therefore, the proton should be directed 10 degrees north of east. So, proton should be directed 10 degrees north of east. Okay. Because that'll give us the maximum, for the maximum vertical force, the proton's velocity should be perpendicular to this field here. And so since it's off by about 10 degrees west of true north, then we would direct our proton 10 degrees north of east to offset that. So then part B is find the acceleration. Now remember that for part B, so this part A, for part B, remember that force is equal to the mass times the acceleration. So then acceleration is equal to the force divided by the mass. And remember that force can be also calculated by the charge of the particle times the velocity of the particle times the magnitude of the magnetic field all over the mass of the object. So if I wanted to find the acceleration of this thing, I would simply write down the charge of a proton, which is 1.6 times 10 to the negative 19 coulombs, and I'm just going to omit the things, times the velocity, which we said was 2,000 meters per second. I'm going to omit the units because I'm running out of space here. So then I also have 0.05 times 10 to the negative 3 Teslas, and then all that stuff is divided by the mass of the proton, which is 1.67 times 10 to the negative 27. Was it a proton? Yeah, proton. Kilograms. All right, cool. So if you plug all that in your calculator, and let me just double check and make sure I didn't make a mistake. 1.6 times 10 to the negative 19, 2,000, times 0.05 times 10 to the negative 3 all over 1.67 times 10 to the negative 27. If I plugged it in my calculator, I should get 9.6 times 10 to the 6, and I didn't write my units, but if I didn't make a mistake, it should be meters per second squared because it's an acceleration. There it is. Boom.